Hello, my name is Steven from MZU doing second semester MBA, and today I will be talking about univariate and variate analysis in research methodology. What is univariate analysis? Univariate analysis is the simplest form of analyzing data. Uni means one, so in other words your data has only one variable. It doesn't deal with causes or relationships, unlike regression, and its major purpose is to describe. It takes data, summarizes that data and finds patterns in the data. You can think of the variable as a category that your data falls into. One example of a variable in univariate analysis might be age. Another might be height. Univariate analysis would not look at these two variables at the same time, nor would it look at the relationship between them. Some ways you can describe patterns found in univariate data include looking at mean, mode, median, range, variance, maximum, minimum, quartiles, and standard deviation. Additionally, some ways you may display univariate data include frequency distribution tables, bar charts, histograms, frequency polygons, and pie charts. Bivariate analysis is used to find out if there is a relationship between two different variables. Something as simple as creating a scatter plot by plotting one variable against another on a Cartesian plane, think x and y axis, can sometimes give you a picture of what the data is trying to tell you. If the data seems to fit a line or curve, then there is a relationship or correlation between the two variables. For example, one might choose to plot caloric intake versus weight. Univariate data, this type of data consists of only one variable. The analysis of univariate data is thus the simplest form of analysis since the information deals with only one quantity that changes. It does not deal with causes or relationships, and the main purpose of the analysis is to describe the data and find patterns that exist within it. The example of a univariate data can be height. Suppose that the heights of 7 students of a class is recorded. There is only one variable, that is height, and it is not dealing with any cause or relationship. The description of patterns found in this type of data can be made by drawing conclusions using central tendency measures, mean, median and mode, dispersion or spread of data, range, minimum, maximum, quartiles, variance and standard deviation, and by using frequency distribution tables, histograms, pie charts, frequency polygon and bar charts. Bivariate data, this type of data involves two different variables. The analysis of this type of data deals with causes and relationships, and the analysis is done to find out the relationship among the two variables. Example of bivariate data can be temperature and ice cream sales in summer season. Suppose the temperature and ice cream sales are the two variables of a bivariate data. Here, the relationship is visible from the table that temperature and sales are directly proportional to each other and thus related, because as the temperature increases, the sales also increase. Thus bivariate data analysis involves comparisons, relationships, causes, and explanations. These variables are often plotted on x and y axis on the graph for better understanding of data, and one of these variables is independent while the other is dependent.